Questions 21 through 25 on the 2015 Grade 10 AMC 10A. Tetrahedron ABCD has AB5, AC3, BC4, BD4, AD3, and CD is 12 over 5 times root 2. What is the volume of the tetrahedron? Let's draw a diagram of this tetrahedron. Let's label this. This is A, this is B, and this is C, which is where we have a right angle. And the reason we know that is because AC is 3, CB is 4, and AB is equal to 5. And 3, 4, 5 is, of course, a right angle. This up here is D. AD, they have told me, is 3. And BD is 4. Now, the volume of a tetrahedron is calculated as follows: 1/3 times the area of the base times the height. And what we can do is look at this diagram and try to figure out what we want to use as a base and as a height. I think I will use this triangle as my base. It'll be pretty straightforward to calculate that area since it's a right triangle. So that will be just 1/2 base times height. I can use 3 as the base and 4 as the height of that triangle. Now the height here represents the height of the tetrahedron. So that is a little bit different. That is here. So that sort of represents the height. I'll write H for height. And what I'll use is this right angle relationship to try to figure out what is the value of that height. And I will label this right here E, this point right here. All right, well, I'm interested in trying to figure out the value for CE. That's going to help me. And I can use the area of that triangle, this triangle right here, to figure out what is CE. 1/2 base times height, which is 1/2 times 3 times 4, is the area of that triangle. But it can also be written as 1/2 base, where AB is the base, and CE is the height. So the halves cancel and I just get 12 AB times CE. But AB is 5. So very quickly we get that CE is equal to 12 over 5. And in a very similar way, I can figure out what is the height represented by DE. So since this is a right angle right here, that's a 3, 4, 5 triangle, 1/2 base times height, which is 3 times 4, which would be the area of that triangle right there, is equivalent to 1/2 base AB times H. And this is going to be 12 over AB, and AB is 5. So H is 12 over 5. So now I can go back and put that 12 over 5 right here and calculate the volume. So this looks like it will be, this 12 divides by that 6, 2. So it'll be 2 times 12 over 5, and that is just 24 over 5. So number 21, the answer is C. Eight people are sitting around a circular table, each holding a fair coin. All 8 people flip their coins, and those who flip heads stand, while those who flip tails remain seated. What is the probability that no 2 adjacent people will stand? Let's talk about this. And we have a scenario where you have person 1, person 2, 3, 4, 5, 6, 7, and 8. And we want to figure out what is the probability that no 2 people stand. And what that means is no 2 people that are adjacent get heads. So like any probability, it's going to be a fraction. The numerator will be our specific condition that we will figure out. The denominator is the total possible. Well, for each person, there's 2 ways of getting an outcome, either heads or tails. And since there's 8 of them, it's 2 to the power of 8 is the total possible combinations. So the probability will be something over 256. So now our task is to figure out that something. So we want no two heads adjacent. Well, we have a few scenarios. We can have everybody get tails. If everybody gets tails, there's no two heads adjacent. And that happens in only one way, where everybody has tails. The other way is we have one person getting a head and everybody else gets tails. Well, there's 8 ways of doing that. The person who gets the heads can be any of these 1 through 8. So that's why there's 8 ways of getting that. Now we have a scenario of 2 heads and 6 tails. Now the 2 heads, the first can be any of these. So let's say I put a head here. But the second head cannot go there or there. It can go any of the other 1, 2, 3, 4, 5 places. So what that means is that for the first choice, you have 8 possible choices for the first heads. And for the next one, I've only got 5. And that's 40. But I've overcounted because, for example, if I chose 1 and 3, that's the same as 3 and 1. So I have to divide this by 2. So that means I've got 20. So far these are my numbers. Now we get to 3 heads and 5 tails, and then finally 4 heads. If it's any more than 4 heads, it won't work. You will never be able to get the condition of the question, which is we don't want 2 adjacent heads. 4 H's is actually a little bit easier. It can be either 1, 3, 5, 7, or 2, 4, 6, 8. Any combination. There's only 2 ways of doing that. 1 way and 2 ways. So now we get into the most complicated part of the question, which is 3 heads. How do we figure that out? How many combinations are there? Well, 3 heads, there's 2 ways, right? The first is if all 3 are adjacent. So for example, 1, 2, 3, if the head was here, here, and here. We don't want those guys. And we also don't want scenarios where you have 2 adjacent and 1 is not adjacent. So something like 1, 2, 5. So something like 1, 2, 5. Well, first we have to figure out what is the total, and then we can subtract these guys and these guys. The total, in a way, is from 8, choose 3. From 8 possible choices, you're going to choose 3 heads. And there's 56 ways of doing that. 8, choose 3. Then these adjacent ones, 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on, right? Those ones, there's 8 ways of doing those. All the way up until you get to 8, 1, 2. And then the ones where 2 are adjacent and 1 is not, that is calculated as follows. The first one and the second one can be paired up in any one of 8 ways. So you can have 1, 2, 2, 3, 3, 4, all the way up until 8, 1. So there's 8 of those pairs. And then the third one, for example, if I put H at 1 and H at 2, the third one can go either here, 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 or here. There's 4 possible choices for the third one. So that's why you multiply by 4 for that third one. And this is 32. So from this 56, you have to subtract this 8 and this 32. And when you do, you get 16. So there we go. I've got to add up this 1, this 8, this 20, this 16, and this 2. And when you do, you get, let's see, 10, 20, 30, 46, 47. 47 over 256 is the answer to this question. So number 22, that would be A. The zeros of the function f at x is equal to x squared minus ax plus 2a are integers. What is the sum of the possible values of a? F at x is equal to x squared minus ax plus 2a. So we can use a quadratic, of course. This will be a plus or minus the square root of a squared minus 4 times 2a all over 2. And this is a plus or minus a squared minus 8a all over 2. Now, we want this to be an integer. The only way this can be an integer is if that radical disappears. So that means this has to be some sort of a integer. And in particular, what we mean is that that radical sign makes that an integer, so that means this is a perfect square underneath the radical. Okay, so now we work with this. This now becomes a squared minus 8a minus n squared is equal to 0. And again, let's use a quadratic on this guy. So a would become 8 plus or minus the square root of 8 minus 4 times negative n squared, all under the square root sign, all over 2. So this is going to be 8 plus or minus 64 plus 4n squared, all over 2. And if we factor out a 4, it'll become 8 plus or minus 2 times 16 plus n squared, all over 2. And this becomes a is equal to 4 plus or minus 16 plus n squared. So for now, a to be an integer, that means that 16 plus n squared must be a perfect square. Well, it becomes a perfect square when n is equal to 0 or when n is equal to plus or minus 3. When n is 0, it would become 16, and that is of course a perfect square. When n is plus or minus 3, it would become 25, which is a perfect square. And when you sub in these values, you get the following values for a. You get 4 plus or minus 4, or you get a is equal to 4 plus or minus 5. So this gives me 0 and 8, and this gives me 9 and negative 1. And they want me to figure out the sum of all values of a. So the sum of all these values, it looks like 16. So number 23, the answer is C. For some positive integers p, quadrilateral ABCD with positive integer side lengths has perimeter p, right angles at B and C, AB is 2, CD is equal to AD. How many different values of p less than 2015 are possible? Let's draw a diagram. Let's try to figure out what this could look like. And I believe this will be a nice way of presenting it. So we have A here, we have B, C, and D. Those are my 4 vertices. And let's start labeling this. They tell me this is 2, so this is obviously going to be 2. The other ones I'm not sure, so I'll call it X and Y. And then they tell me that CD is equal to AD. So that means CD is AD, so this is 2 plus Y. All right, so therefore the perimeter of this is going to be X plus 2 plus Y plus 2 plus Y plus 2. And when you simplify, that becomes X plus 2Y plus 6. Now using Pythagoras on this triangle right here, we can get the following, that X squared plus Y squared is equal to 2 plus Y squared. When you expand, this is X squared plus Y squared. This is 4 plus 4Y plus Y squared. The Y squareds cancel, and all you're left with is just X squared is equal to 4 times, we can factor out and get 1 plus Y. All right, well obviously X is going to be even. It's a multiple of 4. So we can let X equal to some even number, 2Z let's say. And plug that back in just to make math a little bit easier. And we get plug it back into here, and we get 4z squared is equal to 4 times 1 plus y. And that means that z squared is equal to 1 plus y. And now we go back to our perimeter formula and plug it back into there. And when you do, you get the following. Perimeter is going to be x plus 2y plus 6. And let's substitute in our values for x and y. Since we have them all in terms of z, we have 2z here, and then 2y. Y is z squared minus 1, according to that, plus 6. So this becomes 2z plus 2z squared minus 2 plus 6 plus 4. And that's the perimeter. Now what we do is we make a little table of z and p. And remember, p has to be less than 2015. So let's see what we get. If we start with z equal 1, it will be fine. And that'll just be what, I think 8. And we got to keep going. If I get up to 30, I get 1864. If I put 31 for z, I get 1988. If I put 32 for z, I get 2116. So this is obviously not less than 2015. So for values of z from 1 ... all the way up until 31, p was less than 2015. And for each value of z, you can get a matching value for x and for y. You will, of course, use the positive value since these are distances. So 1 to 31, that means there's 31 possible ways of doing this. So 31 possible values of p. Number 24, the answer is B. Let S be a square of side length 1. 2 points are chosen independently at random on the sides of S. The probability that the straight line distance between the points is at least 1/2 is a minus b pi over c, where a, b, and c are positive integers, and the greatest common denominator of a, b, and c is equal to 1. What is a plus b plus c? And greatest common divisor, that is. All right, well, we've got a few scenarios here. The first one is, I'll just draw them out. We've got one square, we've got another square, and we've got a third square. Now, the first one is a scenario where the 2 points are on opposite sides. So we choose a point here, and then we choose a point on the opposite side. Now, when we draw a line between those 2 points, I hope you can clearly see that it's always going to be greater than 1/2. It's actually going to be greater than 1, because this square has side lengths 1 and 1 all the way around. So if I have a point here and a point here, even if I have them completely opposite each other like that, and I draw a line, the minimum distance is going to be 1. And if I draw a line on the slant, it's always going to be greater than 1. So the probability that that distance between those 2 points is greater than 1/2 and I'll label that D here. The probability of D being greater than or equal to 1/2, which is what the question is saying, at least 1/2 is 1. So that's pretty straightforward. And this scenario, this first scenario, happens 1/4 of the time, right? If you choose a point here, the second point can be either here, 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 or here. But I put the second point on the opposite side here, so that's 1 out of 4. So this happens 1 out of 4 of the time, of the total. All right, so that's the first scenario. The second scenario is when both of the points are on the same side. So for example, this is one point and this is a second point. And we want the distance to be greater than or equal to a half. So points are on the same side. And we have to figure out what is the probability that that distance is greater than or equal to a half. Well, that's going to happen basically if there's a couple of scenarios. Let's say I call this guy A and I call this guy B. Well, clearly for this line AB to be greater than a half, B has to be greater than A plus a half. Right? If A, for example, was 0, let's say this represents 0, then B's got to be at least a half. If B was, say, if A was, say, here, which is 0 point whatever, 2, let's say, then B's got to be at least 0.7. See what I mean? So that's where we get this inequality. Another inequality is the opposite. If we reverse the conditions, we could have them as B less than or equal to A minus a half. So for example, if we reverse them, so I put A here, they're on the same side, and B is here, and A, say, is 0.8, then B has to be less than or equal to 0.8 minus a half, which is 0.5. So B has to be less than or equal to, what's that, 0.3? So B has to be less than or equal to 0.3, so let's say it's 0.2. And that indeed would make the distance from A to B greater than or equal to a half. So those are the two inequalities that must hold true. Now those two inequalities, we have to graph them. And when we graph them, it will be a scenario where we can figure out the probability. So if I graph these now, I'll just make a square here where this represents A and this represents B. So this right here, B is greater than or equal to A plus a half, is essentially the midpoints, the line between those two midpoints. So like this. And then the other one where B is less than or equal to A minus a half is the line between those two midpoints. So this scenario right here. And the area of those two represent the probability. So this whole thing was 1, so this is a half, this is a half. So the area pretty much is 2 times those two triangles, and each of those triangles is 1/2 base times height, where the base and the height are both a half. So this is a quarter when you multiply it all out. So this probability in here is a quarter right there. Okay, and this happens, this scenario happens 1/4 of the time of the total. Right, because if you put something on one side, you have 4 possible choices for the second point. You can either put it here, 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 or here. I've chosen to put it on the same side, so there's only one out of the 4 possible places. So that's why it's 1 out of 4. All right, now we get to the last part. And the last part is when the points are on adjacent sides. So for example, one point is here and another point is here. And I've got to make sure that the distance between those 2 points is at least a half. So if this is A and this is B, I've got to make sure that distance is at least a half. So the probability of that, of D being greater than a half, is what I have to now figure out. All right, well, if this is A and this is B, and this is obviously a right angle, I can use Pythagoras. A squared plus B squared is equal to 1/2 squared. So A squared plus B squared is equal to a quarter. But how am I going to graph that now? I was able to graph it on the previous one pretty easily. But now what's this? Well, I hope you can recognize that this here is really the equation of a circle. It's the circle where A and B are obviously between 0 and 1. So we're only looking at the first quadrant, where this is A and this is B. And the radius of the circle is a half. So first let's draw in our boundaries, which would be 1 and 1. And then we have to draw in a circle that has a radius of a half. So something like that. And we want the probability as follows. We want anything that is equal to a half, but also what's going to be perfectly valid is if it's greater than a half. For example, if I'd made a line like this, or if I made a line like that, that's fine. So really what we want is A plus B is not just equal, but it's actually equal to or greater than. So it's like this. Now on this graph, if A plus B was equal to a half, it'd be just that line right there, that part of the circumference. But it's greater than, so it's basically this whole region right here. And that is the area we have to figure out. Well, that area will be as follows. I'll do it over here. So now we have to combine our findings. Our probability will be this 1/4 times this 1 plus this 1/4 times this 1/4 plus this half times this 1 minus pi over 16. So now if we combine, we get 1/4 plus 1 over 16. Multiplying this out, we get 1/2 minus pi over 32. Get a common denominator. It'll be all over 32. This will be 8 plus 2 plus 16 minus pi. This becomes 26 minus pi over 32. And that is of the form A minus B times pi over C. So that means my A is 26, my B is 1, and my C is 32. Greatest common divisor of 26, 1, and 32 is indeed 1. So now all I have to do is figure out the sum, A plus B plus C, and that is 26 plus 1 plus 32, which is equal to 59. So 59 is the answer to this question, and that would mean 25, the answer is A.